Getting started with CyberSift is relatively easy. Once you log in and you navigate to the CyberSift logging engine, you're going to be welcomed by a customized Kibana distribution. One of the customizations that we have is in order to help you with setup, which is the CyberSift NIFI. CyberSift NIFI is based on an open source project called Apache NIFI, and we use it as an alternative to several other open source projects to help you ingest data. In this example over here, I'm just going to set up a very quick syslog to CyberSift ingester. In order to keep things organized, I will create a process group and call it demo. This creates a new group down here. I'm going to add a syslog listener. We, as in CyberSift, provide customized plugins for CyberSift NIFI to help you, which means that we have a syslog parser. If we type in CyberSift over here, you'll see a list. We're interested in this, the CyberSift syslog parser. And once the syslog is parsed, it's ready to be put into Elasticsearch, which means we can drag our last processor, put Elasticsearch, and we're ready to wire these things up. Each processor has different settings for you to configure. For example, an obvious one over here would be the protocol and port of syslog. Let's say we'll put it 515 instead of the normal 512, 514. Hit apply, and we'll just connect it to the next one. Next, we'll configure the syslog parser. Now, over here, the parser asks you to select the model of firewall that you have. We have a number of predetermined vendors. If your vendor is not on the list, all hope is not lost. You can still create your own templates using familiar things like grok as well. In this case, let's leave it as a sonic wall. We'll hit apply, and the last thing we need to do is wire it up to Elasticsearch. Elasticsearch, again, we're prompted. Really and truly, all we need to put in is our onboard Elasticsearch instance and the index that we'd prefer. So that's about it. Once we hit start, we would have a ready-made ingestion pipeline. This can scale from very simple deployments like what you see over here to rather complicated ones like we have for this particular test lab, where we have multiple firewalls all feeding in to the same Elasticsearch deployment. So this scales to quite a large degree. Obviously, this same process is not limited to just syslog and firewall. We can also use it for things like collecting Windows logs or alerting. Now, we realize that for some certain beginners, it's not as intuitive to use a CyberSift NIFI, so we're coming up with deployment templates. If you click on deploy template here, you're given currently two types of templates: alerting and WinLogBeat. Now, WinLogBeat is an interesting one because it lets you collect Windows logs using an open source agent called WinLogBeat. Once you click on a deploy template and click save, it's going to go ahead and create a new process group. I should refresh that over here, WinLogBeat, and we see it basically created the template for us, which is accepting requests from WinLogBeat, routing them, putting in context, which is one of our customized processors, and putting them into Elasticsearch. So as you can see, it's pretty straightforward. There's nothing much. Alerting also works in roughly the same way. You can build very simple or very complex alerting pipelines. One example that we have over here is a simple email alert where we define a particular query, for example, everything going to a particular IP address, and as soon as we get something there, we will send an email. We have processors for emails, we have processors for Slack, we have processors for webhooks. So in reality, you can get some extremely interesting alerting being done, and it is extremely flexible, so it can cater for anyone's needs. If you recall, in our previous video segment, I spoke very briefly about context addition. I mentioned that our custom-built plugins, such as the syslog parser, do some context addition. Now, context addition is something that we do that for every log entry that we receive, we parse it, of course, and we check with several threat intelligence providers, one of them being us ourselves, and we inject data fields that make it easier to understand what's going on from a security point of view. Every time we add some addition context to a log entry, we tag it, context addition true, and if we search for it in this test lab, we'll end up with a large number of log entries. To give you a practical example of what we do, let's say we have the source address of every client, the destination address. These we get from the firewall. The extra part that we put in is the ASN description. This makes it a lot easier for you, even without any input from your firewall vendor, or maybe you have a very basic firewall. It makes it very easy for you to understand where the traffic is going to or coming from. Over here you can see very good examples: DigitalOcean, Google, Microsoft, and so on. So it just makes it easier for you to write queries and draw insights from your data about where traffic is going or coming from, which is something that even our AI algorithms use. Another thing that we do is, like I mentioned before, we check these threat intelligence fields, which is what this OTX field is. We have a number of threat intelligence providers. Most of them are open source. For example, you can see over here, apparently this particular IP that's hosted on Google is actually part of a command and control center that had been flagged by this particular threat intelligence field. So maybe that is something you'd want to log into. This is why whitelists don't always work. Even though an IP address is hosted on Google's, maybe it's cloud infrastructure, it might still be a bad actor. There are plenty of other examples, like you can see over here. This is again a scanning host. It's been blocked by firehall provider. So again, it lets you query for those hosts or that traffic which maybe you should pay a bit more attention to than the rest. In order to help out, you can see that the IP addresses are actually clickable. The internal ones won't give you much information. However, if you click on one of the IPs, a new window will open up, which takes you to an open source threat cloud, which lets you get a bit more, even more situational awareness. So this particular IP address is part of some SDK enhancing miracle.com, so probably it's to do with advertising. And like this, you can build a better picture in your head of what's going on in your network. We try to make it as seamless as possible for you to understand if a particular abnormality is a real threat or if it's a false positive. This is yet another example. You see, it doesn't give you that much information. However, these reverse DNS are give you a better sense of what's going on. So, like this, will help you quickly home in on that traffic, which should be given more attention than the rest. So I just mentioned before our AI algorithms and abnormality detection. I'm going to take the opportunity to show you a bit behind the scenes what goes on. So every hour, on the hour, we run a number of machine learning algorithms, and once they ingest the data and process it and make their decision, they would add yet another field, like we've been seeing so far, to the data that's been collected by Elasticsearch. Now, to show you again a practical example of this, let me open a saved search, which automatically finds the abnormalities for me, and I'm going to add the field to my display showing the abnormalities found. Now, obviously, one of the abnormalities is if it's a known bad connection via OTX, our context edition. But let's ignore that for now. Here we have a bunch of connections that have been marked as abnormal with FT, which means fast text. In other words, it they these connections are in some way or another anomalous when compared with the baseline. In some cases, the machine learning algorithms actually manage to give us a bit more helpful um, insight into why something is being marked as anomalous. For example, over here you can see number of connections, number of the source address, average services. You know how many, basically how many services this particular IP address is connecting to, and so on. What is interesting is that our machine learning algorithms do not use anything, let's say, extra from the firewalls. And this particular firewall that we're showing right here is a Palo Alto, which thankfully gives us a bit of extra information in the application field. So what actually turns out to be interesting is that without any knowledge of the application, our machine learning algorithms fast text realize that incomplete connections are out of the ordinary. BitTorrent connections are also out of the ordinary. Um, so over here we're seeing that basically almost all of them, which are incomplete, are caught as anomalous um, by the machine learning algorithm. Um, some of them might be false positives. For example, this source address average services is pointing towards SharePoint, which in actual fact, if it's the only customer or client that you have using SharePoint, will generate this abnormality. But by and large, it is quite on point, and especially if you have a bit more of an advanced firewall such as the Palo Alto, the combination of application field and the anomaly really helps you figure out what is going on. But next we're going to explore a less, let's say, hands-on, a more visual way of exploring this data. And we do this using either the inbuilt reports from Kibana or using the Entity Explorer. Let's start with CyberSift Entity Explorer. As you can see, it's quite obvious over here. The machine learning algorithms picked out that one particular source IP address is using BitTorrent. That we got to know with the help of the Palo Alto. So let's dig a bit deeper into the activities of 10.45.14. Maybe as an analyst, you would like to know a bit more what other side effects this source IP is having on your network. So one of the customizations we've done to Kibana within CyberSift is the CyberSift Entity Explorer, and that's going to show us a graph-based explorer which allows us to start off by exploring an entity, an IP address or a Windows computer name. Let's put in the source IP of the client that we were interested in. We'll click on save and we're shown this blob. If I right click on the node, we're given a couple of options. As I mentioned, the context addition is useful because it allows us to do exactly what you're seeing here. Show traffic that comes in by ASN, the users that logged in on this PC, and so on. Let's start with the top ASNs that this source computer visited. So you see there's a bunch of them, all of them roughly with the same amount of bytes. That's the size of um, the size of the ball over there. Some of them are very normal, like Akamai. Some of them are not, like this Philippine long distance telephone company. But let's see which ASNs the machine learning algorithms and our threat intelligence providers flagged. That's the anomalous ASNs over here. And we can see that in fact the Philippine company is one that's been flagged. So I have a bunch of others. Now if I tap on this entity, this node, I'm giving a list of anomalies over here, and in fact it says that, listen, it's been flagged by our threat intelligence providers. One of our machine learning algorithms, two actually of our machine learning algorithms, especially because this ASN has a high average number of services, a high average of open ports which this client is connecting to. If we want even more detail than this, we can click on the raw logs, which will send us to a prepared screen in Kibana that pre-populates a particular search. We want this on FileBeat. So you can see there are three filters over here. Everything is prepared for us, and it filters the raw traffic on which it based its decision. And in fact, you can see that it is true that there is a really high number of destination ports. One would assume that this is also BitTorrent. In fact, it probably is BitTorrent, even though the others are incomplete. So this is actually very similar to what you would have in port scanning or a worm or some other kind of malicious piece of software. So now we can go and speak to the user because he's breaching policy using BitTorrent. Just to reiterate, we don't rely on this information that is coming in from the firewall, the application, because your firewall might be so basic that it doesn't include that information, the application information. Everything is done based on behavioral analysis. This segment of our video brings us to the inbuilt Kibana reporting, visualizations and dashboards, which is an extremely effective way of visualizing the data that we collect and the anomalies that we, as CyberSift, point out. And they give you it's a very good way of an analyst logging in first thing in the morning, seeing what went up in the past 24 hours, and then proceeding with his day. If you're familiar with Kibana, this is going to be quite easy for you. Kibana gives you a number of visualizations, area, gauge, goal, etc., etc. You can even build your own if you know how to, using Vika. However, even for non-technical users, this is very easy to set up. As a practical example, let's say we would like to focus a bit on those the extra information that CyberSift gives you over and above the plain log entries that we get. Let's build a pie chart, right? And we're going to be working on firewall data. So we'll click on file beat, and let's set this to the past, well, to today. And we're going to split the slices. So right now we're seeing one big slice. I would like to split that. And I'd like to split that to see where traffic is going through. So I'll use the field that I mentioned before, which is the ASNs, which CyberSift context workers inject into our data. And I'd like to see the top 25. And now you can see that today, I think just about half the traffic went to Microsoft, quite a good number went to Google, Facebook, Akamai, and so on. So we're already getting quite a good idea of what's been going on. However, you can now further subdivide these into seeing where anomalous traffic has been going to. So let me add a sub bucket. Again, I would like to split these slices. And now I would like to see the amount of traffic going towards ASNs which have been marked as abnormal. So I'm going to look for the field which I already mentioned before, which was the abnormal nodes. I'm going to see the top 5, and I'm going to click play. And now we see that actually going towards Microsoft, we've had about 42% which have been marked as anomalous because of the number of connections, which in this case seems to be a false positive, because it just looks as if Microsoft is the largest contributor towards traffic. However, it could also be that a malicious server has been spun up on Azure Cloud, which would mark as Microsoft. For example, here we can see that Apple has one particular IP address in Apple has been marked as an anomaly with source address average bytes. So this basically means that normally when speaking to Apple, clients don't normally send this amount of data. This could be indicative of a data exfiltration, someone trying to upload confidential documents or things like that towards Apple Cloud, Apple iCloud. Obviously, everything over here is filterable. So let's say we know that Microsoft is very probably not going to be a problem, so I would like to filter it out. And automatically everything gets adjusted. Same for Google, same for Facebook, and there's same for Apple. So every time the visualization changes. Conversely, rather than leaving things out, for example, I would just like to see anywhere where I have number of connections being marked as an anomaly. So I can click on play here, and we see that I have two sources, this OVH FR, which is a virtual machine hosting provider, I think, and DataStream, which is a local IP. By tapping on these filters, I can pin them, go to the Discover tab, and everything is filtered for me already. So now I can see exactly who is talking to what. I can, click on the IP address like we've seen before to get a bit of extra details about what this country, IP address this might be, and every time it lets you figure out what is anomaly and what isn't. Obviously, this was a very simple visualization that we just saw over here. You can put visualizations together to form dashboards, and these dashboards can be quite as complicated as you like, as visual as you like. For example, here is one that shows the destination traffic on a map. It shows you the top destinations which we built on the fly just now. In terms of ASNs, the source and destination traffic by client IP. So you can see that most of this, which clients are talking to Google, which ones are talking to Microsoft, and so on. And then we come to some more interesting ones. For example, these are all the known threats. In this case, it's maybe a bit too dense, so you would want to use those filtering tricks that I've shown you before. For example, let's focus just on this PayPal phishing. We would click on a plus. It automatically filters everything, and we can see that there were 1, 2, 3, 4 internal IPs communicating with external IPs that have been marked as participating in phishing. These IP addresses were hosted on SendGrid in the US, and yep, pretty much like this, we immediately have a list of potential problematic clients that we need to investigate. And then we can just reset the filters, and we come back to the dashboard that we had before. Changing the timeline is also quite simple. Again, if you're very familiar with Kibana, this is exactly the same sort of workflow, and every time it allows you to see exactly what CyberSift has picked up, both in terms of known threats and in terms of anomalies, as we've seen throughout this video.